Okay, today we are going to look at expanding our answers when we solve these quadratic functions, and instead of the set of real numbers, we're gonna have some imaginary numbers, okay? So, how would you do this problem? How would you solve this? I heard subtract 8. Subtract 8. And then what would you do? Divide by 2. And then what would you do? Square root of both sides. And normally, if we were using the set of real numbers as our solutions, you would say
No solution.
no solution. But now we're going to expand our number system in all, we're gonna say all numbers, so real and imaginary. So now, we're gonna show you, I know that you don't know what two numbers multiply to give you -4. You don't know how to simplify this, or you may from previous years. But we are going to open the door now and say all numbers, real and imaginary, okay? So, we're gonna be able to deal with a situation like this now, when it says, when the directions say solve using all numbers, now you can finish this problem. Okay, what I need for you to understand, the square root of -4 is, think of this as the square root of -1 times the square root of 4, right? Does everybody agree with that? -1 times 4 is -4. Now, we know what the square root of 4 is. What is the square root of 4?
2.
It's 2. Now, I'm going to tell you that when you have this square root of -1, it is equivalent to the letter I. So, everybody, I want you to understand that the square root of -1 is going to represent an imaginary number, I. So, the answer to this is going to be 2I. And again, don't forget, when you're solving x squared equals, you have your plus or minus 2I. Okay? So, that is how we will deal with a square root of a negative number. The square root of -1, square root of -1 is equivalent to I. Okay? So, looking at our notes, we are going to expand our set of real numbers, and we're going to include all numbers, which are real and imaginary. So an imaginary number will allow us to take the square root of negative numbers, because I is equal to the square root of -1. Now, if I is equal to the square root of -1, if we squared both of these, if I is equal to the square root of -1, if we square this side and we square this side, we're going to say that I squared is equal to -1, because you have two, you have this is equal to the square root of -1 times the square root of -1, and we said when we have a pair of the same, that number comes out. So you have to memorize that I is equal to the square root of -1, and I squared is equal to -1. Remember those two items, and you'll be all set with this section. Okay? So now let's practice how to simplify these. Using I, how would we simplify this? Well, this is equal to -1 times the square root of 16. And what did we say the square root of -1 is? It's I. And what's the square root of 16? 4. Now, normally we put the number in front, so it's going to be 4I. Okay, next one. We've got 5 times the square root of -1 times the square root of 121. Well, what's the square root of -1? I. And what's the square root of 121? 11. Now, obviously, we're not gonna leave that 5i 11. What are we doing with these three? We're multiplying. So what would you write for an answer? 55i, good job. And a little bit more challenging. This one is saying -1 times the square root of -96. Well, we can take the negative out. When we take the -1 out, what do we get? -1i. Does everybody agree with that? Okay, now, this is like what we did last week. We're gonna take the number 96 and we're gonna break it up. What? This is an even number, so 2 goes into 96 48 times, right? And isn't 48 6 times 8? And isn't 6 2 times 3? And isn't 8 2 times 4? And isn't 4 2 times 2? So what we have, 96 is a combo of 1, 2, 3, 4, 5 2s and a 3. So remember, square root means every time you get 2 of the same number, you pull that number out. So if we were to simplify this, we can take out a 2 there and a 2 here. So what are we really taking out? 4. So it's -4i root what? Root what? 6. 6 does not come out. It stays underneath the radical. Yes.
6 comes from 2 times 3, right?
Yes, this is what was not paired up right here. This 2 and that 3 was not paired up. These 2 2s came out and these 2 2s came out. So 4 came out. Yes.
Well, why don't you do anything with like the 6, like the 8 or the 4?
Well, the 6, this is 6 right here. This represents that 6. So this is 6, and these 3 2s are the 8. 2, 2, 2, that's the 8. You get it? Okay. Anybody else have a question? Yes.
I'm confused where the -4s.
The -4 came from? Well, do you know where the -1 was? That was, the -1 is here. That's -1. Then this, see, there's a -1 here. That's the I. And then 96 is 2 times 48, 6 times 8, 2 times 3, 2 times 2 times 2. So you have to pair up, and every time you get 2 of a kind, you take that number out. So like, what if I had -2 times the square root of -12? Let's do this. Let's do another one. Okay, -2 is just a number, -2 outside. But see this -12? This is -1 times 12. Do you agree with that? Right? The -1, this represents I. So we're going to take this out and make it an I. So what we have now is -2i and then root 12. Are you with me? Now the 12, you go like this, 12. What times what is 12?
3 and 12.
3 times 4 is 12, and 4 is 2 times 2. So every time you have 2 of a kind, look, there's 2 2s there. So that 2 is going to come out. What do we do with the 2 and this -2?
Multiply.
Multiply. So you get -4i and then root 3. This stays. This is out. Okay? All right. So, let's say we had a problem like this. Let's say, whoops. I have no eraser. Let's say I had this problem. One has no lead and one has no eraser. So you have to use 2 different pencils.
Why don't you just put the lead in the mat of the eraser?
Yeah, I guess I'll have to pop it out. Okay. Thanks, Dwayne. All right, how should I solve this one? How should I solve that?
Square root, both sides.
Square root of both sides. Is everyone cool with this? We did this last week. Square root of both sides. Okay, so we can handle this. What do we do when we have two quantities that are the same and we're taking the square root? What do we have over here? We just have x minus 2. Does everyone agree with that?
Mm-hmm.
Now, what did I tell you to do with this?
3i.
3 what?
3i.
3i. Now, didn't we write plus or minus when we did
Oh,
these?
yeah.
Okay, so we're still gonna do that. Now, what do we do with this 2? This negative 2, I should say.
Subtract 2.
You're
Okay,
going
2.
to add the opposite. So do you agree that your answer is 2 plus or minus 3i? Yes? Okay. What you have here is a combination. You have two answers. You have 2 plus 3i, and you have 2 minus 3i. What the 2 is, does everybody agree that the 2 is a real number? And do you agree that 3i is an imaginary number? Yes or no?
Yes.
So 2 is a real number and the 3i is an imaginary number. Same with this. The 2 is a real number and the negative 3i is an imaginary number. When you take a real number and mix an imaginary number with it, we call this a complex number. A complex number is a number that's real plus imaginary. This could be minus also. So when you take a real number and an imaginary number and put them together, we have a complex number. We're going to do stuff with these complex numbers. So in your notes I have here, a complex number is any number that can be written as, I want you to write a plus bi. A plus bi. Where a is going to be the real part and bi is the imaginary part. So look at my problem I just gave you. I said 2 plus 3i or 2 minus 3i. Which, we're going to write this in the a plus bi format. The a is going to be the 2, and the bi is the 3i and negative 3i. Okay? This is how you will write these answers. You're going to write them in, this is called standard form. The real number comes first, that's the a value, and the b value is the 3 or the negative 3, and the I is the imaginary number. So now, I want you to look at these. These are complex numbers. And I want you to make them in the a plus bi format. I want you to tell me what's the a value, what's the real number, and what's the imaginary. So look at this one, a. Tell me what the real part is. It's the negative 7. That's the real number. That's the real part. What's the imaginary? Right here. So A is negative 7, B is 3, I is I. Now look at letter B. Can you write this as a complex number? Yeah, you can. 0i. You can. So 6 would be the real part, that would be the A, and bi would be the 0i. How about C? What's the real part?
Negative 2.
0.
Oh.
0, and the imaginary part, that's your bi. So A is 0, and the bi is negative 2i. All right, now, did you know that you can add or subtract complex numbers? You can take a complex number and add or subtract. You can multiply and you can divide. So let's practice adding and subtracting. These are really easy, guys. If you took, this is a complex number, 4 plus 2i. 4 is the real number and bi is the imaginary. Can you add a complex number to a complex number? Yeah. What do you think you combined?
The like terms.
Yeah, like terms. So what would 4 plus, this is what half your homework is today, is doing this kind of stuff. What is 4 plus 2i plus negative 6 minus 7i? Go ahead, Dwayne.
Negative 2 minus 5i.
Yep. that would be the A value, and that would be your BI. And you're gonna put it in A plus BI format. Okay, how about letter B? What do you think you're gonna do?
7, or, we 7 plus 1I,
How'd you get 7?
distributed the negative.
Robert distributed the negative, so it's negative, negative, so it's plus 2, and negative, negative here is plus 3I. So everyone agree, he said 7, what did you say, Robert?
Plus 1I.
1I. Now, do you need the 1? No, just like 1x, you don't need the 1 there. Okay, now, do you recall what I told you, that the square root of negative 1 is I, but what is I squared equal to? Negative 1. So every time, remember this, every time you see I squared, replace it for negative 1. So, like I said, you can add, you can subtract, you can multiply, and you can divide. What are they asking you to do in this problem? They're asking you to distribute negative 2I times 2 minus 4I. So what would you do? You would multiply this, right? Negative 2I times 2 is?
Negative 4.
Mm-hmm. What else? What's negative 2I times negative 4I?
Negative 8I squared.
What is it?
8I squared.
8I squared. Now, what did we say I squared is equal to? That is equal to negative 1. So what is 8I squared equal to?
Negative 8.
Negative 8, good job.
So is negative 8 the real number?
Yep. Dwayne, can you say that again?
So negative 8 is the real number?
Negative 8 is the real number. If negative 8 is the real number, how should you write your answer?
Negative 8.
Yep, that's the format. You put the real number first and minus, or plus or minus, whatever that is, the BI. Excellent. How about letter B? What are they asking you to do? Foil, thank you. So, how do you foil this? You do first, what are the first two numbers multiplied together equal to? 12, then outer. What do you get?
Minus 3i.
Then what?
Inner.
24I. And then minus 6I squared, right?
Which is also
Okay, so what would you do?
simplify.
Simplify what?
Negative 6I.
What is negative 6I squared? What's this equal to?
6.
6. Because I squared is negative 1, and negative 1 times negative 6 is 6. So this whole thing is really 6. What do you do with that 6?
You add it to 12
Good.
or subtract it? to
You would
12?
add it, because it's a positive 6.
Oh,
So,
okay.
so 12 and 6 is what? 18. What do I do with negative 3I and 24I? What do you get?
21.
Now that's in standard form, it's A plus BI format, right? Last one, what do you think we should do? We got a little bit of a mess on our hands here. You think you're gonna foil this yet?
No.
No, what could we do with this piece and this piece?
Square.
We could change that to what? What's the square root of negative 4? 2 what? I. We learned that was the very first problem. What does negative 20, square root of negative 25I equal? 5 what? 5I. Now you're going to FOIL. Now FOIL. Okay, help me out. What's 3 times 2? 6. 3 times 5I minus 4I and then minus 10I squared. Okay, what should I do next?
Simplify.
These add up to be what?
11i.
11I. And what about these two? What do they add to be? 16. Thank you, Ashley. 16. Because I squared is negative 1. Negative 1 times negative 10 is 10. This goes to 10. and 10 and 6 is 16, so that's your answer. And that's in standard form. Okay? Now, every imaginary complex number has a conjugate. I'm going to show you. If I gave you 1 plus 3i, the conjugate is 1 minus 3i. If I gave you negative 2 minus 4i, the conjugate is negative 2 plus 4i. If I gave you 1/2 plus 7i, 1/2 minus 7i. If I gave you negative 6i, it'd be positive 6i. So, see these? These are all complex numbers. These are the conjugate. How did I get the conjugate? What did I do? Opposite of what?
The B value.
Yes. See this sign right here? It's the opposite, the conjugate. Why do you need to know that? Because at the very last two problems, you're going to have to rationalize the denominator. And what you're going to do is multiply by the conjugate of the bottom, not the top, the bottom. What's going to happen when you FOIL them? You're going to get rid of any radical in the denominator of the fraction. So let's start off by, for example, 5. Give me the conjugate of 8 plus 5i.
8 minus 5i.
That's super easy, right? What's the conjugate of 6i?
Negative 6i.
Okay, good. So now let's do the conjugate of the bottoms, the denominators, so we can get rid of any. See, this problem has a radical in the bottom. I is negative 1, square root of negative 1. We don't want any square roots in the bottom. So what would we multiply the top and the bottom by? What's the conjugate of 5i? You're going to multiply the bottom and the top by negative 5i. Both. Why do I have to multiply both the top and the bottom by the same number? Because that's equal to 1, and you can multiply a fraction by 1 and you're not changing the value, right? So watch what happens when I multiply the top and the bottom by the square, negative 5i. What you get here, you're going to FOIL. You're going to do negative 5i times 3 plus 10i. And then you're going to multiply negative 5i times 5i. Okay, so what do you get on top? Help me out.
Negative 15i.
Negative 15i
Minus 50i squared.
minus 50i squared. Over, what's these two multiplied?
Negative 5i squared.
Negative 25i squared. Now, we don't want any I squareds. So let's get rid of these I squareds. What's I squared equal to here? Negative 1. And what's negative 1 times negative 50?
50.
So is it okay if I change this to 50 but put it in front? You guys okay with that? 50 minus 15i over, what does this equal right here? 25. A plain old 25. Anyone see something that they can do in this problem?
Top and bottom.
By what? What number goes into all three of these? 5. So can you reduce all three of these by 5? 5 goes into 50 how many times? 10. 5 goes into 15? 3, and 5 goes into that. So your best answer is 5 minus 3i root 5. Whoops, I'm sorry, 10. 10 minus 3i over 5. That's your best answer. Now some people will separate these and write 10 over 5 minus 3i over 5, and then what they'll do is they'll write 2 minus 3i over 5. You can do that, that's the same answer, it's just simplified differently. One more, and I'm going to give you guys your homework. What is the conjugate?
4 plus
4 plus 2i. How'd you get that? 4 plus 2i. You have to multiply the top and the bottom by the conjugate of the bottom. So now let's multiply across. let's make one big fraction bar. And let's FOIL the numerator. What is 2 times 4? 8. What's 2 times 2i? And what's 8i times 4? 32i. And what's 8i times 2i? 16i squared. Don't simplify anything yet. Now let's do the bottom. What's 4 times 4? What's 4 times 2i? 8i. What is negative 2i times 4? Negative 8i. And negative 2i times 2i is negative 4i squared. Now, what you're going to notice in the bottom, these two will cancel out. They will always the conjugate will cancel these two middle ones out. You'll always have a minus sign here until you clean up this. What's negative 4 times negative 1?
4.
4. What do you do with 4 in 16? What do you get? 20. Everyone cool with that? 20 in the bottom? Guess what? There's no radical in the denominator. That was our goal, and we did it. We got rid of the denominator, no radical in the denominator. By multiplying by the conjugate. Okay, next, how can I clean up this top part? I know what those two are. It's 36i, right? Right? What's this?
Negative 16i.
That's really negative 16. And you've got an 8 here. What does that become? Is everyone cool with that? What I just did?
Well, you could simplify it.
Yeah, what number goes into negative 8, 36, and 20?
2.
2 does, but is there a bigger number?
4.
4. 4 goes into all three of these. So if you pull a 4 out of all these, what do you get?
2.
Negative 2 plus 9i over 5. If I asked you what the A value is, what would you tell me?
-2.
What is the A value? Negative 2 over 5. What's the B value? 9/5. And what's the I value? I. So it's 9. So if
Wait,
I
what?
wanted to write this in A plus BI format, you would say negative 2/5 plus 9/5 I. So that's the A value, and the B value is 9/5 I. Okay? Now, I was nice, and here's your homework. You're going to do all these problems. I'm going to give you this half sheet of paper. On questions 13 through 17, it says to plot the complex number. Tomorrow, I'm going to show you how to graph these, and I'm going to show you how to find the absolute value. For today, I just want the conjugate of these. This is really easy. So for questions 8 through 12, I want you to just simplify. For 13 through 17, I just want the conjugate. That should take them 30 seconds to do that. These are add, subtract, and multiply. And then these last three, I want you to get rid of the radical in the bottom. So multiply by the conjugate. It's all you have to do. It's short and sweet. And tomorrow I will show you how to graph these and solve equations with the I. Like kind of what we did at the beginning. Okay? So,